Welcome to the Mechanical Toolset webinar. My name is Kayla Tenedorio-Cardi, and I'm the host today. I'm joined by our presenter, Sean Bryant, who will introduce himself shortly. Before we begin, a few notes. First, our safe harbor statement. The presentation today is made based on our current expectations. Things can change. Purchasing decisions should not be made upon reliance on these statements. And with that, I will turn it over to Sean, who will introduce himself.
Thanks very much, Kayla. And you're probably wondering, who is this guy? I'm the owner and lead consultant of CAD-FM Consultants over in the UK, hence the accent. And I'm also owner of the blog Not Just CAD, which you may have seen out there on the internet as well. Written for various publications. My voice tends to be the thing that people recognize. I'm a LinkedIn learning instructor, previously lynda.com. And I kick out a lot of AutoCAD content over on the LinkedIn learning platform. So I often get sort of comments along the lines of, oh, I recognize your voice. And yeah, it goes along like that. I've been an AutoCAD and Revit consultant and trainer for many years with 32 years of AutoCAD experience, 11 years of Revit experience. I'm also an Autodesk expert elite, and I work closely with Certiport and AMD as a subject matter expert. I'm also a singer-songwriter with a little bit of music out there on iTunes and other outlets. That's my little bit of therapy away from all the CAD stuff. And there's a second album which has been under construction for some time now, which I must do something about. On a slightly more humorous side, I've been known to sound like the Geico Gecko, which I didn't know existed until I went to AU one year and presented one of my classes there, and then I looked it up on YouTube. To much hilarity. So if I sound like the Geico Gecko, hopefully it'll raise a little bit of a smile. And I've also been known to be Ricky Gervais's stunt double, according to the AU management team as well. That's a little bit of a private joke. It's based on the fact that I do resemble him somewhat physically. And what we're going to look at today is AutoCAD, including the specialized tool sets. And the tool set we're going to be looking at is the mechanical tool set. But just before we start, I just want to kind of get you understanding the concept of the tool sets now, because when you sign up to AutoCAD, your regular AutoCAD, with a subscription, you also get now these 7 other tool sets. So you get the architecture tool set, electrical, mechanical, MEP, Map 3D, raster design, and plant 3D as well. And all of those tools there in the tool sets allow you to work in those specific disciplines with libraries and various other bits and pieces. So as I go through the next few slides, I'll explain those kind of concepts to you. So AutoCAD, including the specialized tool sets, the key benefits. Now this is in full AutoCAD only. You don't get these specialized tool sets with AutoCAD LT, I'm afraid. The reason being is it utilizes all of the API technology in the full AutoCAD. So when you've got intelligence there, you've got libraries of symbols, parts, and detail components, and all of these libraries and symbols and parts allow you to work in your specific industry. So today we're looking at the mechanical tool set. So we'll have libraries of things like nuts, bolts, screws, washers, etc. This then makes you faster because you're automating the creation of all of that information. And one of the lovely things about the mechanical tool set is it creates all the annotations, layers, and properties of those symbols and parts in your drawings and your designs. The good thing is, though, you're still in the AutoCAD interface, so it's all familiar to you, but you're using industry-specific tools, which again increases efficiency because you can extend those workflows across your different disciplines. In this case, it's the mechanical discipline, but you might be using something like the electrical toolset or the architecture toolset in those specific disciplines as well. You still get all of the usual subscription benefits. So you subscribe to AutoCAD and obviously AutoCAD LT, and you would get all of this for your flexibility and support. So you get the technical support, so you can talk to support specialists, get remote assistance, online resources as well. The software stays up to date on your subscription, so you get instant access to the latest features, any upgrades to new versions, and so on. One of the major benefits of the subscription is the flexible term lengths. So you can use the software for as long as you need it. So you might have a specific project that needs the mechanical tool set. You can use it for as long as you want to, with your subscription. So you can go from 1 month up to multiple years in that specific subscription if you need to. And of course, you've got the admin tools there as well. So you can manage all your software licenses, your seats, your usage. As an ex-CAD manager, I wish I had administrative tools that we have now, because it would have made my life probably about 200 times easier. But that's me going back and showing my age a little bit there. But the technology now with the administrative tools is just so much easier to use. It's really easy to manage those software licenses. Now, we're talking about the mechanical toolset today. So we did a recent study, a productivity study a little while ago about productivity gains in the mechanical toolset. Now, you'll notice there's a little asterisk right there after toolset in the slide. If you look down at the little caveat at the bottom, that's compared to basic AutoCAD. So we're getting a 55% gain over basic AutoCAD. Now, that was a specific study. Your results might differ, and we're offering this information as is without any warranty. You might get a better productivity gain, for example, but you might also get a lesser productivity gain. It depends on what you're doing, obviously, in the mechanical toolset. Bullet points wise though, for 2D CAD work, we're looking at a total time reduction of around 55%. Production drawings, including say a bill of materials, up to around 65%. And detailing and optimizing new tray clamps, you'll recognize that in a moment when we look at the drawings we're working with. It's like a robot arm with clamps that lifts up a box. And those new tray clamps in the productivity study were up to 46% faster. So again, I'm talking about the caveat there. If you were doing something a lot more detailed, you might get a better or lesser productivity gain, depending on the actual subject matter that you're working with. So just be aware of that. We're saying it's an overall productivity gain of 55%, and that may differ depending on what you're doing. Let's have a little look now. You can see in that slide there's our robot arm and there's our clamps. If you look at the magenta color bits there, the clamps are holding the box up, and you've got the robot arms there on the little crane, and it lifts that box up with the vertical lines on it. And that was all in the productivity study, and the productivity gains in total, as I mentioned in the previous slide, were 55%. So what we're going to look at today are just some of the elements from that productivity study. I am going to use some different drawings as well, not just the robot arm that you can see there as well. We're going to look at how we design new mechanical components as compared to basic AutoCAD. We're also going to look how we place and optimize those new components, and how we can prepare assemblies with details as well. One of the lovely features of the mechanical toolset is you can calculate forces in an assembly mechanism. So if we're looking there at our robot arm, for example, we can calculate the forces in a certain area in the drawing, and it gives us a good guide of whether that design is actually physically going to work in the real world or not. Also, preparing production drawings for assembly, you want to make sure that you've got a parts list, a bill of materials, so that when they go out to assembly, everybody's got everything to build what they need to build. Also as well, we're going to look a little bit at how we communicate design intent with our production drawings. The one thing that we are aiming to do here with the mechanical toolset is communicate that design intent. So when it leaves our CAD office and goes out to the people that are going to manufacture our design, they know what to do with it when they put it into production. So let's get going now. Let's move into what we're going to talk about. And the first thing we're going to look at is designing new mechanical components. Now, the time saving for that was approximately 45% in the productivity study. I'm using a slightly different drawing it's different to the one that we use in the productivity study. It's a little pump subassembly, and I really like this one because it gives you a good general overview of the mechanical toolset. Now, when you're using layers and properties in basic AutoCAD, it's not a difficult task, but there's lots of little manual things that you've got to do, and they can become quite onerous, but more importantly, time consuming. So what we want to think about here is, how does the mechanical toolset actually speed us up, so to speak? Now, these little videos, they're pre-recorded, so I'll just talk you through what's going on. So we'll start the video off now, and you can see we've got the sub-assembly there, and I'm just moving over now. We've got the mechanical browser. Now, the lovely thing about the mechanical browser, it's a palette. You can auto hide it on the screen if you need to. And the nice thing about it is, though, is it lists all the parts that are in your sub-assembly, in this case, the little pump sub-assembly. And the benefit you have there is all these parts are stored in a content library. And when you're working with the layers, it's a very different layer manager. You'll notice in the layer manager there, we've got different colors, different line types that are specific to the standard that we're using. We've also got, if I slide along there, associated objects. And you'll notice the mention of the word contour in places there. Contours are used in the mechanical tool set, and what they do is you'll pick something like a hidden narrow line type or a center line, and it will automatically place it on a known layer. And that's the major benefit of these contours, is it automatically and automates those layers for you. And that means that you don't have to think about it. You know it's going on the right layer straight away. In the annotation here as well, you'll notice in the text, based on the standard we're using, we've got different multi-line text at different heights. So I don't have to go in and set the height or set the text style height at all. I can automate that, and I can say that I want it that height. If I go back to the Home tab, hatching is similar. I've got different hatch patterns preset already with my standards that are driven in the mechanical toolset drawing. I can still hatch normally though. You'll notice there I can still pick an internal point and hatch if I want to. Nothing to stop me doing that whatsoever. So the whole idea there is that all of this detail is quick and easy to work with. And it's just a great tool. And I love the mechanical tool set because there's so many things in here, like center lines. You can have center lines in so many different configurations. You don't get that in regular AutoCAD, but I wish it was there. It would make my life so much easier in regular AutoCAD if I had all these different center line configurations to use, especially when you're drafting simple things up and you need a center line cross in the corner of a polyline, for example. Other things available as well are your construction lines. Your construction lines are fantastic. You've got so many different types. In regular AutoCAD, you've got 3. So you can see the difference there in the mechanical toolset. And they're brilliant for transposing different views. At the moment, we're looking at a side view of the subassembly, and I've got all those different construction lines there that allow me to create contours and construction lines to develop different views of the subassembly that I'm working on. I can delete them all as well, you'll notice there, and there's some extra ones if I go to the flyout there on the construction panel as well. Now, you've got your hidden lines as well. There's all different hidden lines that have numerous configurations in there as well, and allow for different scales and proportions when you're detailing in the mechanical toolset. And you'll notice there we've got the bill of materials and we've got the little green balloons there. Those balloons are a standard revision, you'll notice there. They work to a specific standard. So the diameter of the bubble, for example, is a specific size. The arrowhead is a specific size, and it does all of that automatically on the appropriate layer for you at any given time. So you don't have to think about which layer does that go on? What diameter does that bubble need to be? You don't have to think about it. And you've got your parts list there as well. That is automatically added when you work from the bill of materials. So there's my parts list, and I can go in and edit that, edit the configuration of the parts list. I can also go in there very quickly and just quickly edit the attributes of my title block. Again, that's all attribute driven. So you can see there I've got a standard DIN title block, and you can see I can go through all my tags there, my attribute tags, and make sure that I'm communicating the appropriate information on the drawing. It's that quick and it's that easy. And this is what I love about the mechanical toolset. It's taking all of that donkey work out of the drafting and allowing you to concentrate on the design. Okay, moving right along now, what we'll do is we'll jump into how we detail and optimize new components. So we've got lots of different commands that allow us to enhance the basic AutoCAD drafting. So on one hand, you're saving time here, but on the other hand, you have easier access to commands now that you might not know about. So you've signed up to your AutoCAD subscription and you've loaded up the mechanical toolset, but you're used to regular AutoCAD. So when you jump into the mechanical toolset, you might find commands that allow you to work much smarter, much more efficiently. So there's numerous options for line, centerline, and rectangle creation, for example. So let's run the video and we'll jump into some of these now. And the whole idea of these is it gives you the ability to work in the toolset quicker and faster. And I'm hoping that my crosshair will move soon. There we go, that's excellent. So if we jump into the line command there, you'll notice you haven't just got the line command anymore. You've got symmetrical line, zigzag line. Zigzag line is great for breaks in a design. different center lines that I mentioned earlier. Now, you'll notice that there's lots of different ones in there, but if I'm designing those 4 holes on that pump assembly there, I can actually place those 4 hole center lines just in one go, instead of having to draft them all up. The rectangles, though, I love. I've got so many different configurations of rectangles I can work with. I can decide on what size I want it to be, where the midpoint is. I can do the same with squares as well. So they're equal-sided rectangles, you might say. So the tools there are so quick and easy to use. And if we zoom in a little bit now and I say click on that object there, can you see that is a specific object from a specific part of the library? If you go to the content tab, which I don't do in this video, I hasten to add, but you can see there that I can jump in and change the length of that really quickly and easily. It takes me a couple of seconds. The reworking I would have to do in basic AutoCAD, even if it was a dynamic block, would be a lot of work. It's really quick and easy. So I'll undo that and obviously put it back because it was protruding out of the sub-assembly there. But the whole idea of this is it's all standards-based manufacturing. Now, you've got some nice tools here when you're dimensioning as well, your annotation. One of my absolute favorites is the power dimensioning in the mechanical toolset. So if we jump into that a moment, and I'll specify my origins like you would for any regular dimension, and I'll just click there. And as soon as I click, it doesn't just place the dimension. It places the dimension as if I'm going to be using the DD edit command. So I can go in there, I can edit, I can take away the actual dimension value, or perhaps add my own information as well. Now, I did mention about construction lines as well. Construction lines are amazing as well. Now, we've only got the one view here on the drawing, but we might want to edit this and expand and have some different views of the pump subassembly. So you've got automatic construction line creation based on a specific configuration. So I'll pick those 2 lines there and quick enter after selecting them. And there's my construction lines in place straight away. So I can place that view over there to the right, maybe use a bigger title block and expand my drawing as well. So it's just incredibly easy, really fast and easy and quick to use. Now, I want to show you the hatching as well. The hatching's really clever because I can pick just a standard hatch pattern. Now, I'm going to show you a really good mistake that people often make. Make sure that your hatch boundary is closed before you hatch. Otherwise, you get that kind of issue. But the hatch pattern there was preset. So it was all the right size on the drawing. If I come in here, though, let's perhaps hatch that area. And again, the hatch pattern is the right size, the right angle. It's automated. I don't have to think about it in my hatch command. It's already there and ready to go because I've got a standards-based list of hatch patterns to use. So really quick and easy. And to optimize your design, you then don't have to think about all of those variables behind, say, your hatch pattern, your dimensioning, your construction lines, and so on. We're now moving into the 3rd video of the series in this webinar, and we're going to take a look at preparing our assembly with detail views. And you can see there's a fairly significant time saving there of 86%. Now again, remember that caveat, it might not be exactly 86% when you do it. It might be more or less depending on the complexity of your design in the mechanical toolset. Now we're going to be working with the robot handling cell with the robot arms again. And what we're going to look at is how we set up detail views that have different properties. We're talking hidden detail, solid lines, line types, etc. Now, in basic AutoCAD, there's a lot of manual work for that, and geometry manipulation is needed to accurately represent the objects that are partially or completely hidden. So you have to create separate views of, say, hidden detail and maybe not hidden detail, for example, just to make it really simplistic. But the benefit you've got with the mechanical toolset is you don't have to do that. But obviously, when you're doing this in basic AutoCAD, it's really time intensive and tedious. And it reduces any time available for mechanical design. And I've been there when I want to hit a deadline, having to create different views in basic AutoCAD. So how does that work in the mechanical toolset? Well, let's zoom in and have a look now. I'm looking at the gripper assembly part of the robot arm. So we're going to zoom in. You can see the box there with the vertical lines, and the robot arms are clamped in, holding that box up at the moment with the clamps. Now, what you create in your mechanical design in the mechanical toolset is what they call a hide situation. And the hide situation basically has different properties. So you go to hide there, it's in the detail panel on the home tab on the ribbon, and you create a new hide situation with your hidden detail, your center lines, your continuous lines to represent the view at the front, so to speak. But if you want a view at the back, you can go in and work with these details and give them different properties. So you might have dashed lines to represent hidden detail instead, for example. Now, what I'm going to do here is go into two of the hide situations I've created for you. So we're in the gripper assembly, which is highlighting in the mechanical browser there. I'm just going to go in and expand that out and look at the front view. And you can see I've got some hide situations there. I've got two. And it's basically the left-hand robot arm and the right-hand robot arm. And I've set those up and they're really basic and simple. But what I'm going to do is I'm going to use the edit tool to edit the hide situation so that I can show you the difference between a hide situation and a regular. So it's sort of front and back. It's a bit like draw order in other Windows-based applications. So there's one there. And you can see the hide situation automatically puts that to hidden detail. If I go to the next one, again, you can see another hide situation, and you can see I've created some different ones there just around the robot arms in the gripper assembly there in the design. And the whole idea of these hide situations is it allows you to highlight elements in the drawing itself. So I go to the hide situation, I right click on it and I highlight, and there you go, it highlights it in that view. Now the benefit I've got there is if I want that view to be part of a scaled viewport to communicate my design intent in a drawing, I can utilize that. And again, I can highlight again, and you can see the hidden detail just pops up. And what it does is it's two different views of the same object, but you're looking at them in different locations, sort of front and back, or one at the front and one behind it. And that's why these hide situations are so useful, because it basically allows you to not have to do all that work that you might do in basic AutoCAD. You can see there that I'd have to create two separate views, one with hidden detail and one without, in basic AutoCAD. But as you can see with the hide situations in the mechanical toolset, it automatically highlights those two different views. And the good thing about it is as well, is when you go back to the regular view and you switch off the hide situation, all of the elements of your project are also recognized in your parts list and your bill of materials as well. So if the design changes, all of that workflow and process into the bill of materials and the parts list is still maintained. So you can see where you get that massive time saving from of nearly 86%, again with the caveat, with your mechanical toolset when you're preparing the assembly with the detail views and the hide situations in your project design. So this is another really fantastic tool in the mechanical toolset. It allows you to calculate the forces in the mechanism itself. And we're going to zoom in on an area in the drawing where we can actually calculate some forces. Now, there's a little hatched area in the top view of your robot arm. You can't see it at the moment, but hopefully we'll zoom in shortly. But the idea being is we're going to jump into this robot handling cell and make sure that we calculate our FEA, our finite element analysis. So when we zoom in, we're going to get in nice and close, and it's that little hatched area there. And we need to zoom in a lot here because this is quite a small part of the design. But I jump to the content tab and I can run there my finite element analysis. And what it asks me now is where am I going to highlight to calculate? So I pick a point, a bit like if I'm hatching, and then I get the calculation dialog box up here. Now I've got to add my loads, I've got to add my supports here. Now, some of the values I add, just ignore them because I'm just showing you the workflow here. They wouldn't really apply in real life. So there's one of our supports, supporting that little edge that's bending round at the top of our mechanical design. And I'm going to place another support there. So this is like sort of a lip coming off of the edge of part of the robot clamp that we've got. So what I need to think about now is where is there going to be a load bearing down on those supports? So I'm going to place a load, and again, a little bit of zooming and panning. Just going to place a load on that corner there as if it's pushing down on the top edge of our little robot clamp that is working with our robot handling cell. It's like a crane that lifts boxes. So there's a load there, and I'm just pushing it straight down, and it's 1,000 newtons I've put in there. Now that value might be totally random. It might not actually work. Now, bear in mind we're a 2D drawing, so we need to give it a thickness of material to calculate with. So I've put 25 millimeters in there for now. And I'm going to click on the visual results. There's all different results you can get, but if I click on the visual results there, I can have something like a von Mises stress diagram. Now, you may remember those with all the nice pretty colors. You can also have lines, so you can choose which one you want. I like the colorful one. And it calculates it for me. So all those different colors now represent the stresses and strains on that particular part of my robot handling cell. I can now drag that away from the design, click in an area of the drawing, put my legend there as well, click again. I might want to scale that up a little bit, make it bigger. And then it takes me back to the dialog box. And if I zoom in real close now, look at that. It tells me all the different values that all those different colors represent. You can obviously see that the major part of the stress and strain there is pushing down on that corner where that 1000 newtons is pushing down. And that's also kicking in on the bottom sort of right corner there to the left as well. But the benefit you've got there is you can do a quick finite element analysis of any mechanical design, which means that you can almost non-destructive test it there and then. It's not a perfect science, but at least it gives you a good idea of what you're designing is potentially going to work as you go through all the different design phases. Now, we're jumping back to how we prepare production drawings now for an assembly. Now, this is where you start thinking about your bill of materials. Now, your bill of materials gives you a time saving of in the region of 68%. Now, don't worry about all the different time savings because I do kind of overview those towards the end of the presentation anyway. So we're back to our nice little pump subassembly. Now, I like this one purely because it's a nice, simple little design. You've got a parts list, you've got a bill of materials, not too many objects, and it's really good for showing you the overview of how the bill of materials works in the mechanical toolset. Now, the good thing is once you've created your bill of materials, it stays there in your mechanical design in the drawing. It's always there. And if you add other parts to the drawing and the design, it will update the bill of materials and the parts list as well. So you don't have to think about that too much. So when you're preparing these production drawings for assembly and you suddenly get a sudden, oh, I need to change that or I need to add a component, it will automatically calculate that for you, add it to the parts list and add it to the bill of materials. So let's run our little video and we'll see how the bill of materials works. And the whole idea of the bill of materials is it's actually allowing you to work with all the information, all the content libraries that you've got in the content tab on the ribbon as well. So you've got support there for multiple parts per drawing, collapsible assemblies. You can automatically recognize your standard parts because they're already in your libraries. Change your design once, the updates go through all the design, the entire drawing, keeps everybody on schedule, and it also reduces any costly stops in production from an error as well. So what you can do as well there is export out. So one of the lovely features is you can export out from the mechanical toolset as well. That can go out to things like proprietary ERP and MRP systems, and also as well Autodesk Vault. So you'll find the BOM on the Annotate tab. As you can see there, we've jumped into that. And what you're doing is you're creating part references. So you can use a part like a line or a center line, or you can use a block. So all of these objects in the drawing, if I go and select an object, I can give it a part reference. I just go and pick on it and it's there and it adds it to the bill of materials. So you can see there I can select a block if I want to, let's say one of those bolts going through the sub-assembly. I can do either of those. So it would be, for example, a center line could potentially go on the parts list because it might be representing something in your design. Now, the bill of materials itself, once you've started adding those part references, the bill of materials picks up on that automatically based on the standards-based information that you've got in the drawing. As you can see there, I just hovered over the parts list. The parts list is a reflection of your bill of materials. So I'm just using the standard main bill of materials template in this drawing. That's why I'm using it. It's nice and simple rather than get sort of buried in the weeds. So what I'm going to do there is I'm just going to specify my main bill of materials. Now you'll recognize that list. The parts and the numbers are the same as in the parts list that is physically on the drawing. Now I'm just using the standard bill of materials template here. I haven't done anything fancy, but there you can see I can add a part reference if I add an object to the drawing itself. And I can also zoom in on an object that's already in the bill of materials. And I can also as well highlight. So you can see I have part references there. I can split cells in the bill of materials, and it's a bit like an Excel spreadsheet. Now, talking of the Excel spreadsheets, obviously you can export out as well, which is really easy. But I can zoom into an object or I can highlight an object. So I've selected one there, and as you can see, it's highlighting that particular part reference that is in the bill of materials in the drawing itself. And what's really nice is if I look down at the command line, I can go to the next item in the bill of materials and just work my way through. It's really quick and easy. And once you've got it all set up, think about how this is going to save you so much time. All these objects are in the libraries in the mechanical toolset. There's an extensive group of libraries that are available. So you can see zooming into an object, it automatically zooms me in as well. Very quick and easy to use. And I can export out, like I said earlier. There's the report generator. I can generate a report. I can export out to, say, an Excel spreadsheet format or an MDB format there. And the information can go out to other people if necessary as well. It's really, really quick and easy to use. And I just cannot believe that it's not used more, because the tools here are just so fast. And you'll see that I'm going into the parts list now, and it's saying which BOM do I want to use, bill of materials. So I'm going to use the main one again just by pressing enter there. You can see it on the command line, and I can right click and select it on the shortcut menu. And there's my parts list again. So the information's there. I've just got to say, okay, I want a parts list off of the bill of materials, and there it is in the drawing. It's that quick and easy. And the benefit you've got there is, imagine having to set up all the AutoCAD tables in basic AutoCAD to do all of this. It would take so much time. And what I love about it is it's just there. I just click and it's there. The parts list is there, and it relates to that bill of materials that is all automatically assigned to my mechanical design. Okay, last but not least, let's hope the PowerPoint's going to behave itself again. There we go. It's the same drawing, still the pump subassembly, but I'm going to show you now just some really nice little features that are available when you're preparing your production drawings. So again, a time saving of approximately 62%. Now, in newer versions of basic AutoCAD and also the tool sets, you have a lovely feature now with the blocks palette. The blocks palette allows you to quickly and easily add blocks to your AutoCAD drawings, but it's also got a lovely libraries function as well. Let me show you how that works. Just starting the video up there. And what we're going to do now is just pop over to the Insert tab on the ribbon. Now, the idea here is that we're going to work with the blocks palette, and I'm going to show you a way whereby you can potentially have all your blocks that you're using on a project stored in a remote location. So I'm going to go down to recent blocks, not use the blocks that are already in the drawing. So there's recent blocks, there's the blocks palette. Now you've got three tabs. You've got the blocks in your current drawing. You've also got the recent blocks that you may have used in AutoCAD as well. So when you click on the recent tab, those are all the blocks I've used recently. So we've got some chairs and things in there that I've had in other drawings. But the libraries, I just specify where I want AutoCAD to look, or in this case, the mechanical toolset. Now this is the same in AutoCAD and all the toolsets. So if you've got a group of blocks on a project, let's say the pump subassembly, and you want people to use them, there's my title block. I can just drop that straight in. And there's my title details, which is the little bit in the corner there with all the information about the drawing. It's that quick and it's that easy. And I've got all the insertion options there as well. It doesn't take long at all. So as you can see there, you've got the ability to bring blocks in. I'm using the title block, obviously, as an example, but it doesn't have to be a title block. It could be other information that comes into your mechanical toolset design. So that's a really nice little feature there that's available. Let's zoom extents now. And I'm going to say to myself, okay, it's Friday afternoon, and I've got a last minute grub screw that I need to apply to that shaft on my pump subassembly. So I go into content. I'm now in my content library. There's my screws. I'm going to pick a specific type. Let's go for a countersunk head. Obviously, it's a grub screw. You don't want it catching on anything. So I'm going to go for the slotted flat countersunk head cap screw, that one there. So I select that in the library. Okay, which one do you want? Which view do you want? This is where the content libraries come into their own. It saves you so much time. There's so much information in the mechanical toolset. So what we've got now is, I'll pick a point, just a random nearest snap there, and I'm just going to drag that horizontally. I want it going into the shaft, off the top of the shaft there, and I pick a size. So I click on finish, and there it is there. Because it's from the content library and it's utilizing the dynamic block technology, there you go. I can pick the length and the part size, and it's just all menu driven. I just say okay to that. I can add a hide situation. There we go, where our PowerPoint decided not to play. We're deciding on whether we have a hide situation, and it highlights in the drawing. I'm just going to say okay to that, and yes, we will have a hide situation. And you'll notice the line going behind the grub screw is now hidden, and that's what I'm talking about with the hide situations. Now you'll notice as well, we have a new element now on our parts list in the drawing. Now what's happened there is, because I've selected that from the content library, it's automatically added that to my bill of materials. So when we go to the bill of materials now and just select the main one, I've now got a new item, item number 9, which is my slotted flat countersunk head cap screw. It's that quick and easy. And there you go, I can highlight it in the drawing if I need to. Just saves a huge amount of rework and demonstrates exactly why the mechanical toolset is so useful for mechanical design. So that last minute change on a Friday has literally taken me a few minutes. Imagine the rework that would have taken in basic AutoCAD. Would have taken quite a while to do. So the information is there, content libraries are there, it saves you a huge amount of work. Now that 55% that I talked about at the beginning, think about that for a moment. If you're working on a drawing for, say, about 4 hours in basic AutoCAD, you are nearly halving the time that it takes to create that drawing in the mechanical toolset. It's not a bad statistic when you think about it. Another thing that you have that is available across full AutoCAD, not AutoCAD LT, I hasten to add, but all of the toolsets, is the application programming interface. Now, a lot of the things that you've seen in the videos are all based around the application programming interface, the API. And the other thing that you get with all the toolsets as well is the app store as well. So all AutoCAD toolsets offer an application programming interface. You can see it there. It's that little box top right with the load application, run script, etc. The applications panel on the AutoCAD ribbon. So what that allows you to do is use user programming to automate tedious time-consuming tasks. That user programming allows you to then develop apps that will benefit the AutoCAD toolset users in your team. Those apps can also be purchased in the Autodesk App Store. You can see that there, the middle graphic. And also as well, once you've got those apps loaded up as well, you can potentially go into them in AutoCAD. You can see AutoCAD 2021 there at the bottom with the connection to the App Store. And you also get highlighted apps as well sometimes that pop up in your featured apps tab in AutoCAD and the toolsets as well. So let's have a little look now at the mechanical toolset and the overall time savings. Let's have a little look at the numbers here. So these are our 6 tasks that we went through, PowerPoint permitting, I hasten to add. But if you look at them, these are the values that came out of our productivity study when we worked on it with the robot arm. So you've got an idea there now of how long it takes in basic AutoCAD and how long it takes in the mechanical toolset. So you go from 136 minutes, which is 2 hours, 16 minutes, to 40 minutes and 30 seconds, just to give you an idea of time saving. And that is compared to basic AutoCAD. The asterisk is there, the caveat is at the bottom, because we're providing this information as is without any warranty, because obviously it depends on the detail of your task, the detail of your project. But the idea is that the mechanical toolset will save you a huge amount of time. And that's the whole idea of these toolsets. We don't want you struggling with basic AutoCAD. Basic AutoCAD has its place. It has done for many years. In fact, if I remember rightly, I think basic AutoCAD turned 39 this year. So it's been on the block for some time, and it still gets used for lots of regular AutoCAD drawings. But if you want to work with mechanical and mechanical design and production, the mechanical toolset is the way to move forward. As you can see, the time savings are there. You cannot miss them. And I've shown you some neat little tips and tricks, again, PowerPoint permitting, that allow you to obviously work with the mechanical toolset. I've only touched the surface though. I really have only touched the surface. There is so much you can do with the mechanical toolset, and I just wish I had 2 or 3 hours to talk to you instead of the 1 hour on the webinar. What I do want to just mention here as well, I don't know if any of you attended AU 2020 last November. It was a very surreal Autodesk University because it was all virtual due to the world situation at the moment. I did a couple of classes. One of them was this one, which is understanding the new AutoCAD, the one AutoCAD with the 7 toolsets. And in my class, my AU class, I go through how to implement the new toolsets, how to perhaps implement some training, how to get the software up and running within your organization. So there's the number there, AS463447. And as you can see, it should still be there on the Autodesk University website itself. If you go to au.autodesk.com, that's the best URL to use. And all you've got to do is search for that number or search for me as well, Sean Bryant. You'll find me on there as a speaker, an AU speaker. I've been speaking at AU for some time. There's plenty of different classes there, not just this one that you can maybe check out as well. I just want to thank you all for your time today. That brings my part of the webinar to a conclusion now. And based on the world situation at the moment, I'd like you all to be safe. And I can't stress that enough, actually, because end of December, I caught COVID and I'm still recovering from a lot of different post-COVID symptoms at the moment. I'm actually on medication for them. I won't bore you with the detail, but it's not a nice thing to get. So be as safe as you can and also be as healthy as you can. Just look after yourselves and others, and also be kind as well. The world is very different right now, and some people are really struggling with this world situation. So just, be safe and just be nice to each other.
All right. We had a question, Sean, about what is your favorite function or command in the mechanical tool set?
Well, that's very easy. I'm a bit of an annotation and dimensioning fan. I'm a little bit OCD about it, actually. They all have to line up nicely. But my favorite function has to be the power dimensioning. I so wish that was in regular AutoCAD, because there's so many times that I place a regular AutoCAD dimension and I want to edit it. The power dimensioning places the dimension and automatically takes me into DD edit. So I've got all that information in front of me, ready to edit the text on the dimension.
Great. I'm just looking through our questions here. Someone was curious if there was a certification for today's webinar. We do not, but you will have, as I mentioned, the recording. We had another question come through about what is your favorite app and the App Store for the mechanical tool set?
It's the Title Block Exchange app. I used it. It's been around some time, actually. I used it quite a while back, and what I love about it is I showed you obviously things like the title blocks and the information that you could obviously utilize through, say, a particular title block and just drop it into your drawing. Well, that information on that title block, if you use the Title Block Exchange app, it allows you to have all of that information in an Excel spreadsheet, and you just literally hit a button and it takes all of that information straight into the title block. So you can have a standard spreadsheet with all the relevant information just sitting there in the background, get a blank title block, hit the button, and it saves you typing it all in as attributes or as text or whatever.
Great, thank you, Sean. There was a question about drawings from the mechanical tool set working in the AutoCAD web app.
Yeah, that's a no-no at the moment. Funnily enough, tested that quite recently, and any of the information like from the content library in the mechanical tool set, it just kind of appears as weird little squares. I think that's all to do with the browser-based technology that the web app uses. Now, that's not to say it won't happen later. I know that the web app is a fairly new thing. It's only been around a couple of years now, and it's a fantastic app, but for what I call regular basic AutoCAD functionality at the moment. Who knows, that maybe the development team for the web app might start considering bringing in specific toolset functionality at a later date. But at the moment, the mechanical toolset does not work with the AutoCAD web app.
Great. Thank you, Sean. There was a question about HVAC and plumbing tool sets, if those are available.
HVAC and plumbing, I would look at AutoCAD MEP, the MEP toolset. That's where you want to look there. And one of the lovely things about the MEP toolset is if let's say an architect has created a project in the architectural toolset, you can use the same project with the MEP toolset. So all of your architectural information is there, your structural walls and so on, so that you can then start looking at all your MEP information and making sure it doesn't clash with those walls and ceilings and roofs and so on. So I would go down the MEP toolset route for things like plumbing and HVAC and so on.
Terrific. Thank you, Sean. And we had a question come through about getting a link to your class. So I went ahead and put that in the questions for everyone to see, as well as in the chat if anyone wants to click on that link and continue to explore the other tool sets, including the MEP one.
The link to the AU class, if you just go to au.autodesk.com using any proprietary browser, obviously, and once you're in there, you will need to log in. You need a login to get into the AU website, and that's normally based around your Autodesk account if you've got one. So jump in, log in, and then all you do is there's a lovely search bar at the top. You can use the number if you want to that's in the slideshow, obviously when you get the video recording of this particular webinar, or just look me up, look up Sean Bryant in the AU website. Once you're logged in, it'll list all of the classes over time that I've obviously presented at AU, and the most recent one obviously is AU 2020, so that will be at the top of the list, and it's the one all about the new AutoCAD, the one AutoCAD with 7 tool sets.
Terrific. Thank you, Sean. All right, well, it looks like that's all the questions we received today. So thank you so much, everyone, for joining us. And thank you, Sean, for this wonderful presentation.
You're welcome, Kayla. Thank you ever so much.
Thanks, everybody.